French company Dassault Aviation has a rich history in making world-class fighter jets and aircrafts. Carrying on this tradition, they have rolled out a fighter jet which is probably the best fighter jet in its class. Hello and welcome to Defense Atlas, your own channel for all the defense-related news and informations. Defense Atlas will be connecting you to world of defense. So without wasting any time, let's get started. The Dassault Rafale, which literally means gust of wind or burst of fire in a more military sense. It is a French twin-engine delta-winged jet with support of canards. It's a multi-role fighter aircraft designed and built by Dassault Aviation equipped with a wide range of weapons. The Rafale is intended to perform air supremacy, interdiction, aerial reconnaissance, ground support, in-depth strike, anti-ship strike and nuclear deterrence missions. The Rafale is referred to as an omni-role aircraft by Dassault. In the late 1970s, the French Air Force and French Navy were seeking to replace and consolidate their current fleets of aircraft in order to reduce development costs and boost prospective sales. France entered into an arrangement with UK, Germany, Italy, and Spain to produce an agile multi-role fighter, which emerged as the Eurofighter Typhoon. But subsequent disagreements over workshare and differing requirements led France in pursuit of its own development program. Dassault built a technology demonstrator which first flew in July 1986 as part of an 8-year flight test program, paving the way for the go-ahead of the project. The Rafale is distinct from other European fighters of its era, as it is almost entirely built by one country, involving most of France's major defense contractors, such as Dassault, Thales, and Safran. Many of the aircraft's avionics and features, such as direct voice input, the RBE-2AA active electronically scanned array radar, and the Optronique Secteur frontal infrared search and track sensor, were domestically developed and produced for the Rafale program. Originally scheduled to enter service in 1996, the Rafale suffered significant delays due to post-Cold War budget cuts and changes in priorities. The aircraft is available in 3 main variants: Rafale C, a single-seat land-based version; Rafale B, a twin-seat land-based version; and Rafale M, single-seat carrier-based version. Introduced in 2001, the Rafale is being produced for both the French Air Force and for carrier-based operations in the French Navy. The Rafale has been marketed for export to several countries and was selected by the Hellenic Air Force, the Indian Air Force, the Egyptian Air Force, and the Qatar Air Force. The Rafale has been used in combat zones of Afghanistan, Libya, Mali, Iraq, and Syria. Although not a full-aspect stealth aircraft, the Rafale was designed for a reduced radar cross-section and infrared signature, in order to reduce the RCS. Changes like reduction in the size of the tail fin, fuselage reshaping, repositioning of the engine air inlets underneath the aircraft's wing, extensive use of composite materials and serrated patterns for the construction of the trailing edges of the wings as well as canards were done in initial technology demonstrator. 70% of the Rafale's surface area is composite. Many of the features designed to reduce the Rafale's visibility to threats still remains classified. The Rafale's glass cockpit was designed around the principle of data fusion. A central computer selects and prioritizes information to display to pilots for simpler command and control. The primary flight controls are arranged in a hands-on throttle and stick-compatible configuration, with a right-handed side stick controller and a left-handed throttle. The seat is inclined rearwards at an angle of 29 degrees, which improve G-force tolerance during maneuvering, and also provide a less restricted external pilot view. An intelligent flight suit worn by the pilot is automatically controlled by the aircraft to counteract in response to calculated G-forces. Great emphasis has been placed on pilot workload minimization across all operations. Among the features of the highly digitized cockpit is an integrated direct voice input system, allowing a range of aircraft functions to be controlled by spoken voice commands, simplifying the pilot's access to many of the controls. Developed by Cruzet, The DVI is capable of managing radio communications and countermeasure systems, the selection of armament and radar modes, and controlling navigational functions. For safety reasons, DVI is deliberately not employed for safety-critical elements of the aircraft's operation, such as the final release of weapons. For displaying information gathered from a range of sensors across the aircraft, the cockpit features a wide-angle holographic head-up display system, two head-down flat panel color multi-function displays, as well as a central collimated display. These displays have been strategically placed to minimize pilot distraction from the external environment. Some displays feature a touch interface for ease of human-computer interaction. A head-mounted display remains to be integrated to take full advantage of its Mica missiles. The cockpit is fully compatible with night vision goggles. In the area of life support, Rafale is fitted with a Martin Baker Mark 16 F00 ejection seat, which means it is capable of ejecting at 0 speed and 0 altitude. Also, an onboard oxygen generating system, developed by Air Liquide, eliminates the need to carry bulky oxygen canisters. The Rafale's flight computer has been programmed to counteract pilot disorientation and to employ automatic recovery of the aircraft during negative flight conditions. The autopilot and autothrottle controls are also integrated, and are activated by switches located on the primary flight controls. The Rafale core avionics systems employ an integrated modular avionics, called Modular Data Processing Unit. This architecture hosts all the main aircraft functions, such as the flight management system, data fusion, fire control, and the man-machine interface. According to Dassault, the IMA greatly assists combat operations via data fusion, the continuous integration and analysis of the various sensor systems throughout the aircraft, and has been designed for the incorporation of new systems and avionics throughout the Rafale's service life. The Rafale features an integrated defensive aids system named Spectra, which protects the aircraft against airborne and ground threats. Developed as a joint venture between Thales and MBDA, various methods of detection, jamming, and decoying have been incorporated, and the system has been designed to be highly reprogrammable for addressing new threats and incorporating additional subsystems in the future. The Rafale's ground attack capability is heavily reliant upon sensory targeting pods, which are Thales Optronics' RICO new generation, Aereo's reconnaissance pod, and Damocles' electro-optical laser designation pod. Together, these systems provide targeting information, enable tactical reconnaissance missions, and are integrated with the Rafale's IMA architecture to provide analyzed data feeds to friendly units and ground stations as well as to the pilot. Damocles provides targeting information to the various armaments carried by the Rafale and is directly integrated with the Rafale's VHF/UHF secure radio to communicate target information with other aircraft. It also performs other key functions such as aerial optical surveillance and is integrated with the navigation system as a FLIR. These targeting and reconnaissance pod are all-weather, night and day capable system, and provides a significant targeting and reconnaissance capability. Rafales are capable of undertaking many different mission roles with a range of equipment, namely with Mica IR and M-air-to-air missiles, and precision ground attacks typically using Scalp EG cruise missiles and AASM Hammer air-to-surface missiles. In addition, anti-shipping missions can be carried out using the AM-39 Exocet C skimming missile, while reconnaissance flights would use a combination of onboard and external pod-based sensor equipment. Also, the aircraft could conduct nuclear strikes when armed with ASMP missiles. The Rafale's onboard store management system is compliant with MIL STD 1760. An electrical interface between an aircraft and its carriage stores, thereby simplifying the incorporation of many of their existing weapons and equipment. Its length is 15.27 meters or 50.1 feet. Wingspan is 10.90 meters or 35.9 feet. Height of the jet is 5.34 meters or 17.6 feet. Total wing area is 45.7 square meters or 492 square feet. Empty weight of aircraft is 15,000 kilograms or 33,069 pounds. And maximum takeoff weight is 24,500 kilograms, 54,013 pounds. Fuel capacity is 4,700 kilograms or 10,362 pounds without drop tanks. The Rafale is typically outfitted with 14 hardpoints and 13 hardpoints on Rafale M version, 5 of which are suitable for heavy armament or equipment such as auxiliary fuel tanks, and has a maximum external load capacity of 9 tons. In addition to the above equipment, the Rafale carries the 30mm GIAT-30 revolver cannon and can be outfitted with a range of laser-guided bombs and ground attack munitions. According to Dassault, the Rafale's onboard mission systems enable ground attack and air-to-air combat operations to be carried out within a single sortie, with many functions capable of simultaneous execution in conjunction with another, which increase its survivability and versatility. The Rafale is fitted with 2 SNECMA M88 engines, each capable of providing up to 50 kilonewtons of drive thrust and 75 kilonewtons with afterburners. The M88 enables the Rafale to supercruise while carrying 4 missiles and 1 drop tank. Its maximum speed is 2,223 kilometers per hour, 1,381 miles per hour, or Mach 1.8 at high altitude, and 1,390 kilometers per hour, 860 miles per hour, or Mach 1.1 at low altitude. It can supercruise at Mach 1.4. Its combat range is 1,850 kilometers or 1,150 miles on penetration mission with 3 tanks, 2 Scalp EG and 2 Mica AAMs. Its ferry range is 3,700 kilometers or 2,300 miles, with 3 drop tanks. Its service ceiling is 15,835 meters or 51,952 feet. Its G-bearing limits are +9 to -3.6 and +11 in emergencies. Its rate of climb is 304.8 meters per second or 60,000 feet per minute. Wing loading is 328 kilograms per square meter or 67 pounds per square foot. And thrust-to-weight ratio is 0.988 on 100% fuel. 2 MA-2A missile and 2 IRA-2A missile. But there has been interest in more powerful M88 engines by potential export customers such as the United Arab Emirates. As of 2007, a thrust vectoring variant of the engine designated as M88-3D was also under development. In short, the Rafale is a force few can tackle. And with all the proposed improvements, no one knows what it is capable of doing. I hope you liked the video. If you did, hit the like button. Please subscribe my channel Defense Atlas. Also touch or click bell icon and select all for getting notifications. Thanks.